Hello, everybody. This is Gabriel, CEO and co-founder of Cassandra. Today, we're going to have a special guest in this live. We're going to discuss how to operationalize marketing mix modeling for tech companies. We have a special guest today, which is Carlos Trujillo, former marketing data analyst for Bolt, one of the fastest growing companies in the tech industry right now, and actual marketing science for Wise, a financial company. He's not only a manager inside of these organizations, but he's one of the biggest contributors inside of one of the biggest open source library for marketing mix modeling, PyMC Marketing. It allows this open source library, it allows companies to internalize with their marketing data science team marketing mix modeling operations. Today, we're going to discuss what are the specific problems that tech companies have when measuring and optimizing their marketing mix. And we're going to analyze and give you some tips and tricks to adapt and adopt marketing mix modeling in your operations. So without further ado, I'll welcome Carlos.
Thanks, Gabriele. I'm really happy to be here, and that's a very nice introduction. So, really, thank you.
Amazing, amazing. So, Carlos, just to give a little context to our audience is coming, can you tell us about your story? I mean, when you started studying marketing science and what led you then to adopt these methodologies inside of your companies?
Sure. That's a very. I will need to travel in time, basically, to go back in time because I started to do marketing in 2016, more or less, when I started like university. Um, at that point, I was working in agencies most of the time. I will say that majority of my experience happens at agency companies like Omnicom Media Group, for example. Um, all of this happens in Chile. I'm from Venezuela, but I moved to Chile like when I was very young. I started to work there, and at some point, I just found that I hate to say it, but we was doing marketing and we didn't saw the results that we were expecting. So we did stuff. We basically went to Google Analytics. We said like we are driving, I don't know, 10,000 sales and so forth. And by the end of the day, like our clients were saying like, okay, but where they are, I'm still selling, I don't know, 200 toys every day or something like that. And then I just crossed with this amazing movie, like The Greatest Hack, again in 2017, almost 2018. I don't quite recall, but that was the time where I saw it. And even if this can be like ethically like not correct or whatever, I will say that from a scientific point of view, they did something like very amazing in Cambridge Analytica with all the data analysis behind. I mean, that's really impressed me. For sure, not for the not for not doing like not following the best practices, but still like the analysis was quite huge, and that just inspired me to start to do data science. So I take like a master in data science. I did it, and I start to move forward like in my companies back then in Chile. And then at some point I get hired by Bolt here in Estonia, to continue applying data science in the marketing field. Um, I was there like for 2 years, as you mentioned it, and now I'm just in Wise, just trying to do it again, but in another different context. So, Bolt was mobility company. Now I'm going to finance, and the business cases are like very different, even if the models are kind of the same, right? Like regressions are regressions, but how you apply it based on the constraints of the business is what really makes the difference. And that's basically the long story short.
Awesome, awesome. And I mean, the Great Hack was so inspiring for me too. I didn't
Yeah.
tell you before, but after watching how this particular agency leveraged data in order to have a huge leverage in one of the biggest countries' decision in US and in Brexit,
Yeah.
I actually reached out to his CEO.
Hmm.
I reached out to him on LinkedIn because
Okay.
I was so inspired, and I was just starting out with marketing mix modeling, and I wanted him to have him as advisor. Most of the
Oh.
Italians, most of the marketing in Italy were not really pro Cambridge Analytica, but I
Mhm.
was, because that was genius. It was just a black sheep that was playing for the wrong privacies regulation that were at the time, because it was a far west at the end,
Mhm.
and they leveraged those these low privacy regulation that there were in the market at the time. But yeah,
Mhm.
we loved it. And from the point in which you started working at Bolt and starting working in this really fast growing company,
Mhm.
what was the thing that made you realize that attribution and digital attribution were kind of not that clear and
Um,
that precise?
to be honest, I would say that this didn't start exactly at Bolt. I would say that
Mm,
maybe Bolt hired me for that is because I was working in Omnicom, as I mentioned it, and there I had clients like Walmart, Huawei, Ports, I don't know, Mercedes-Benz, Gatorade, so forth, Coca-Cola, and a lot of different clients from very different business industries. And I was there leading the team for analytics, basically also the reporting like team. So we was doing not just the modeling and developing like measurement tools for these big companies. We were also at the same time doing the dashboard things. We have like these two verticals, and then I think that I started to realize that something was off at the moment that, as I mentioned, we start to do the reports, we start to deliver the results of our campaigns, and if you see the dashboard, you will say like, okay, historically, I don't know, this company is selling a certain amount of money or of units of whatever, and after our campaigns, maybe you can see a change in that amount of units, but was not so radical as, for example, Google Analytics was saying, or Google Ads was saying, or Facebook Pixel was saying. So I start to kind of realize that something is off. We are saying that we drive 20% of, I don't know, the total sales. I don't see a 20% of increase with my eyes in the dashboard, right? It's just like it's moving, but not quite radical. So once that happened, everything. I mean, MMN was starting. I would say that Rowan was just like very new, and we start to go deep into how we can find a better framework of work basically. And I will say that I love that we call it MMN and we decide to put a very fancy name to all of this, but it's just statistics and it's just like regression-based models. And I knew regression-based models. I was doing my first like regressions in Excel before even know how to program. And I said like, let's, if we cannot trust in these novel methods like Google Analytics and Pixels and so forth, I'm sure that we can trust in statistics. So that's I just drive there, and I again, once I see that Robin and Facebook people were doing it, I said like, okay, we can basically do the same. So we started basically to applying in Omnicon at some point, and then I was that I switched to both for the same reason.
And at the beginning, when you started doing market mix modeling with Excel,
Mhm.
how were your models?
How what?
How how do they? I mean, doing Excel. I started with Excel too, and
Mhm.
it is really cool because it allows almost anybody to start with market mix model, but there are
Mhm.
big limitations in it. One of which that comes to mind is negative coefficients for media contribution, which
Yeah,
is
but
horrible.
no, totally. But I would say that at that time, back in those days, I would say that we kind of neglected because
Mhm.
like we were not mature enough right now. Like statistics and marketing were maybe something that you could match, but we were not in this mature stage where we kind of understand all of this, like, I don't know, intercept cannot be negative, or X channels cannot drive like negative impact or whatever. We need controls and so forth to also understand better our time series. I mean, we were in a stage where kind of you build everything in Excel, you build your macro, and then you get the this small like tab with the coefficients for each column, like E, D, F, whatever. And that was all. And then you said like kind of, okay, I can maybe take decisions. I understand that now my model see Facebook better than, I don't know, Google or whatever, or campaign A better than B, and I move forward. Definitely was not something that we were like using with the same complexity that we are using MMN. But at the same time, again, I'm talking when Robin was created, like maybe the first iteration of Robin. So all the industry about marketing scientists was like super, super new. I remember that I was just searching like these kind of examples in Google, and you could find things around supply chain. You could find things around like a lot of other examples in finance, like, I don't know, how to predict, like, I don't know, demand supply relationships. But anything around like marketing specifics, like, how to find the impact of your campaign in Facebook. That was not a thing at all. So yeah, I would say that at that moment we didn't think about it, and then for sure we start to move, like the market start to evolve, our measurement techniques as well as evolve, and then we basically said like we need to go to a more like deep understanding around it.
What year did you start building these models with Excel in a raw way in order to solve these problem that you faced with Google Analytics?
Like when you mean?
Yeah, when? What year?
2000, maybe 19 or close to 19, again, just after after I just saw the movie The Greatest Hack, I kind of start to studying more like Python, go in depth, and then I start to apply it. Again, I start to learn programming, but I didn't want to wait, learn like full like Python code to apply it. So I kind of basically just said like, let's start to make it in the fastest way possible. In that time was Excel for me, because I knew Excel, I knew regressions, and I said, let's shoot it.
Definitely, definitely. And what year was when you started working with Bolt?
That was 2 years ago, so
2 years ago.
2022, if I'm not wrong. Yeah, 2022,
Yeah,
January 2022.
and I mean, you went from Omnicon, which I understand is a service company that helps big corporation to understand their marketing mix, specifically in your department, to working specifically on one of the big fastest growing company in the world.
Mhm.
Um, how what were the specific problems that you were facing while growing these tech companies in terms of marketing measurements?
I will say that, I mean, after see like Bold, now even Wise, or all the other companies before, I see this common pattern of like marketers, we are being every day more like, again, robust with our comprehension about like how our investment works. So that basically drive to this stage where all the people like from local teams, marketing local teams or whatever, they start to ask like, okay, I want to see my investment like growing first, like giving me results, but even more important, being profitable. And profitable start to be a thing in companies. So it's not only be able to justify that I bring 10 users, 10 sales, 10 whatever. It's this based in the amount of money that I'm spending, and base it on the lifetime value that these my users will bring to my company. What will be my ROI? So, and this is like, again, repetitive pattern. Maybe the conditions to measure like, again, lifetime value, or how willing are we to take risks in a specific market or to invest. That's another topic, but at the same time, like the core problem is, it's basically we need to be profitable. We are in an era where get funds, like get investments for your company is also hard. Either if you're a public, private company, money it's being expensive. Like find money, it's now expensive. And if you want to find it, you also need to prove that you are doing everything in the most efficient way possible. So, and that includes marketing. So I would say that
Definitely,
that's the core reason. Yeah.
definitely. And so companies from starting from 2022 is the year in which the bubble of startups started to explode and multipliers went down. So it's because interest rate increased by a lot. Most tech companies face a real change in their scenarios. They needed to move from growth rate to optimize growth rate to optimize for efficiency. And according to you and your experience, what was the hardest and most difficult obstacle in order to help them achieve that profitability in a marketing measurement field specifically?
I will say that it's very related to switch the perspective of attribution to incrementality. So again, you can do your measurements, you can apply the model, you can get the results, you can actually be like, you can have a very reliable model. But if your stakeholders, aka the people that talk with the main business, because usually data science, we are involved in the business, but we have this person that is the one that is directly connected to C-level, to put it some name, I will say.
Mm-hmm.
And you need to convince them that everything that you are doing, like, it's also in the right direction. And when you switch from attribution to incrementality, what usually happens, it's you found a very huge sectors of a lot of sectors of inefficiency. So maybe we were spending a lot on Facebook, and to be honest, didn't make any sense. So you got, I don't know, 80% of Facebook, and everything remained the same. So you basically say to the stakeholders, let's not invest anymore, or not invest at this level. And they say like, okay, but now attribution is saying that we are losing, I don't know, 200 sales every day. And it's like, no, we are not losing anything. We have like experiments, and we have MMN, and we can combine and do a lot of different tests to prove it. But you need to put them into also the mindset of incrementality. I think that now we are evolving. I think that now incrementality is as well becoming a thing, even for people that is not from statistics. So that's actually helps a lot through the process. But I remember that at the beginning, sometimes you actually spend more time just convincing your stakeholders and having these conversations with them to try to explain how the things works, more than even modeling and doing all the fancy and nice things. So
Definitely. This is an accounting problem. With Cassandra, we face that really often, and which there is a big difference between understanding where your sales come from before buying, which is not the same of analyzing incrementality, and incrementality, same. And what we often do in order to show and prove the optimization scenarios that are there is you need to convince the stakeholder that what the decisions that he made or any one of his team made last year were wrong. There is a high probability that we're wrong, because the only way to increase efficiency at the end is to reallocate your marketing budget in a way that yields more ROAS or more revenue or a lower customer acquisition cost. And you probably are doing something wrong, but this is the human problem. It's not a machine learning or a data problem. We need to be able to narrate stories to stakeholders in order to test some hypotheses that might be true or false. But they have a big conflict with ego that most of the times it's in the middle.
Yeah, I'm not sure if call it to be honest, like ego. I would say that is more like you're used to do something, like you build a framework around it, and now for some reason you need to switch it. And that's not easy. That's like when you emigrate from Venezuela to Chile, you need to kind of switch your mind as well. And I would say that that's the same that is happening right now. We are switching our mindset in marketing from attribution, because and now in July, just like 3 weeks ago, Google just did the release to don't have cookies anymore, at least in their browser. So that will go worse. And the good thing is every time I see more people on board on incrementality, on board on statistics, at least in the basics, so they can understand, and that makes the process like very manageable. But at the same time, we need to understand that we are in this adaptation stage where
Mhm.
we will get set headbacks, and we just need to try to lead with that and in the best way possible. I mean, it's not as well that attribution don't work for anything anymore. I would say that we can still use some information from attribution, but not in the same way that we were doing like before. That's all. So
Definitely,
we switch the mindset.
definitely. From my experience, one other obstacle that we saw with tech companies, but also direct to consumer, it was the data structure. Most of the companies didn't have a data structure, data infrastructure that allowed them to get data really quick
Mm-hmm.
from their companies, and this slowed everything down. And everything was based on assumption because data-driven decisions were too slow. Uh, if you had to share some tips and tricks for companies that start now, tech companies or direct to consumer, B2C, which you have most of your experience on, what what would you say to them?
That's a very good thing to mention. In Omnicon, we were building like data infrastructure for our clients for the same reason. We found out that without infrastructure, like data infrastructure, you cannot start to run models. You cannot start to to do all the fancy things, and sometimes even worse. And this is something that happens to me after I left Omnicon. Your media agencies usually hold all your data, like your media information. They have like the account. So once you go out of the company, they just get all your historical information about the spendings or whatever. And my first recommendation is like any company should be the owner of your data. So you need your ads manager, you need your, I don't know, MCC in Google or whatever else. So you should own your data first place. And once you own it, try to save it. Like I will say, I'm not promoting Google, but I will say the GCP is kind of cheap. You can start to save a lot of information in GCP in a very easy way without so many complications. So just start to store there, and that's I would say like the basics. If you have that, then you can maybe, I don't know, get another tool like Cassandra, or get a few data scientists and bring it to your team and start to build on top of that. If you don't have it, doesn't matter if you hire Cassandra, if you hire data scientists, they wouldn't have anything to work with, I would say. So data ownership is a very important thing. Again, I see a lot of companies going there, but at least in Chile, and again in Chile and South America in general, because I was based in Chile, but my company, like Omnicon, my filial was New York, so we were in charge of all South America, and this was again common pattern around like Colombia, Argentina, Mexico, Paraguay, etc. What's all the time like the same. First, we start to onboard clients into the all data infrastructure. We build these ETLs and this data warehouse for them. We store the data, and once they have all of that, we could proceed with MMN, with experimentation, with AB, with class experiments, so forth and so forth. But that should be the beginning. Without that, you don't have nothing to build on top.
Definitely, I agree 100%. And I mean, it's not only for data ownership and putting in place ETL infrastructure, which is extra transformer load.
Yeah.
This is the acronym for this num. It not only allows you uh, to to do market mix modeling, but
No.
allows you to get more basic essential stuff in
Yeah.
centralized, like understanding descriptive analytics for your business, like contribution margin, understanding unit economics for your company, understanding and sharing this data with potential investors if you want to, if you if you actually raising capital or you want to optimize it and analyze what is the current status of your company. So obviously, this is the best solution. In practical terms, I've started personally with tools like 2 Minutes Report or Supermetrics,
Yeah,
centralizing everything in Excel.
yeah. That's honestly a very good thing to do. I mean, I started as well with Excel, but then I found that Supermetrics now can connect directly to GCP, so to BigQuery. So again, if you ask me recommendation, I would say like forget Google Sheets. I mean, can be the easiest way, but just
Definitely.
save it. I mean, do queries in BigQuery is very easy thing. Sometimes they already have like interface, so you don't need to new SQL to make the query. Sometimes you can just click buttons and get your info.
Definitely, definitely. In fact, when you start to, I don't know, scale up or your number of ads increase by a lot,
Yeah,
and you upload everything, you start getting, I don't know, 100K rows every month, and Google Sheet or Excel start to break up, and Google
yeah,
BigQuery is a really practical solution to this problem.
yeah.
Um, in terms of, so when you start creating this infrastructure, so let's say now, what you think about this statement? Every company should streamline all their data centralized in one place,
Yeah.
regardless of how big they are. After validation, everyone should put in place a data infrastructure to centralize their data into their warehouse.
Mhm.
Now, from my experience, there are three levels of actionability of this data. There is descriptive analytics that we already mentioned. We use this data in order to describe our own company, our own unit economics, understand what's the current status of the company. Then there is diagnostic analytics. We want to understand why certain phenomenon happen. And then we want to get prescriptive analytics, which I want to get prescription to optimize for a certain objective. I want to solve a certain problem. I get prescriptive suggestions on how to do it. Now, what I see in the market is we went from a multi-touch attribution that was mostly descriptive, try to say what is currently happening, to a more diagnostic slash prescriptive model,
Mhm.
in which in marketing mix modeling, we try to understand why we overspent. I mean, why we didn't get that incrementality effect after investing more money into the same channel. We diagnose it, for example, with diminishing returns, or we get prescription by a budget allocator, for example, with PyMC marketing or with Cassandra or with Robin or with our library that actually tell us how we should allocate the marketing budget in order to maximize revenue. And my question for you is, what is the actionability that how actionable and how do you make it actionable for Bolt
Mhm.
while you work there?
Whoa. Like actional the decisions around budgets or campaigns or in
Yes, I
general.
mean, how do you made all this data that you centralize in one place actionable
Hmm.
for the company?
Got it. I mean, I think that you have the three stage. If you're doing marketing science, you need all the stage. For example, the
Mhm.
first, it's once you have your data, you need to start to build your assumptions. You need to start to build your hypothesis about like how things works, right? I mean, when you're doing science, first you get your hypothesis, you define your hypothesis, then you test it. So that's where these dashboards can help you. So you have all the information centralized around. You know how much are you spending, and you can also at the same time in the same dashboard see how much sales are you getting, sorry. And you can just with your eyes do just practical analysis and see if these are like correlated. If once you increase something, another thing increase at least at some point in time. And from that you can start to just get insights about how things works, like very basic, without do any math at all. Then for sure you can go and do this like exploratory analysis where now let's put math into the equation. Let's, I don't know, calculate like Pearson coefficients, or let's, I don't know, do simple like back testing, where I go to some point in the past and I apply some causal analysis there. Once for sure I verify that all my conditions are holding, um, or you can start to apply another like another ways of work. So I would say that that's a stage one, where you kind of understand maybe what can be working and what cannot be working, like what maybe you need to stop. Then even before MMN, I would say that experimentation happens. Experimentation comes, so you start to experiment those hypotheses, and here's where I kind of feel that MMN is an amazing tool. Again, regressions in general, I kind of really like it. They can solve a lot of problems in a very easy way, but at the same time, they are not one solution that fits all. Like every business have different necessities, and sometimes maybe a small company, they don't need to understand like the specific relationship of diminishing returns between their spend and like their returns, because I don't know, they are happy only with understand the ROI, independent of the elasticity of their spend, basically. So I mean, have the elasticity will be amazing for sure. Again, maybe a big company like Bold that have years in the market wants to understand it because he have like several markets, all the markets in a different maturity stage. Okay, but maybe for a small e-commerce that just a few people know, that they just want to understand if their spends are going well or wrong. Maybe sometimes experimentation can solve that question without any modeling. So you do several experiments during the year, and you will, by the end of the day, in my case, that I like Bayesian stuff, you can start to formulate your distribution about how big is your effect, and you don't need MMN for that. You can just purely with experiments get an idea, and maybe that idea is enough to actually continue. I would say that once you move to MMN, is because you have a lot of other relationships around, again, maturity of the market. Some markets are like very mature, others not. You also want to understand, I don't know, you have delay effects that in the case of, again, big companies or big markets, these effects also could be representative. And that's when I was, you cannot wait, I don't know, a year to do 10 causal experiments and then put them together to get a response or take actions. And that's why then you move to MMN. So you can, with a few experiments, you can get causal information from that and then move forward, applying MMN to kind of extrapolate this knowledge. So that's how I see it. That will be, I would say, that the path that I have been walking with the companies that I have been working. And yeah, so I don't know. What do you
This
think?
is really, I mean, I think this is incredibly insightful. And I want to dive into that specifically. What are the main measurement techniques? And if you can share what is the technique in general and what is the library or something practical that our audience can actually leverage tomorrow in their analysis, can be extremely valuable, I think, for everybody. So
Mhm.
summarizing, my question is, what are the measurement techniques and libraries that you use in your operations in order to
Yeah,
provide value in measurements in your
that's
organizations?
that's a that's a tricky question, to be honest, Gabriel, because um, more than techniques, I actually really like to think about it like we are doing causal, like causal. What we call causal analysis is not actually causal. And when I talk about experiments, I'm actually talking about like causal inference experiments. I really like, for example, quasi experiments. I also really like A/B
Yep.
test experiments. And for me, it's like you need all the tools available around quasi experiments. For example, you have like synthetic control groups. You have, I don't know, interrupt time series. You have, I don't know, regular difference and differences. I will usually call it like the mother of all, because that was kind of the first one before all the fancy ones. And And you can find this in several libraries. For example, I love causal pi for sure. I'm like from PyMC, so I really I use it in my day to day. But more important than the toolkits and than the specific um, uh, framework that you're using to measure your causal effect or causal impact, it's the DAG, what we call, like, how you understand that the world basically works, how you define it, how is related one variable with the other,
Mhm.
and how much the assumptions that you're doing around that DAG you can hold. So if, let's say, if I tomorrow want to measure, I don't know, the impact in, I don't know, sales in Android, I could think about that, sales in Android and iOS, maybe they can be like parallel, like they can have some kind of parallel trend. So they are affecting, if I just draw a DAG around it, I can think that I have total sales, and total sales is component for all the sales in Android
Mhm.
and for all the sales in iOS. And these two nodes at the same time are affected by the same things. So again, people in Android and iOS in Rome, they suffer the same weather, they suffer the same seasonality, they suffer a lot of other like external factors. So you could basically make the assumption that I could use one to kind of represent the other, and if something like diverge in the period where I'm doing the experiment, and I'm sure that I hold all my conditions around, I don't know, discounts, promotions, ad spend, and all the things around marketing, I make them stable, then I can inference that this is actually, like, this small deviation is actually coming from the action that I'm measuring. So, and you could do this with a lot of different methods. Again, you could use synthetic control group, you could use interrupted time series, blah, 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 blah. And that doesn't make the difference. What really makes the difference is the underlying assumption and the underlying conditions that you are holding. So yeah, I would say that more than the tool itself, make your assumptions clear, um, draw this hypothesis about how do you believe that your target variable, sales or whatever, is um, it's built. What are the factors that are affecting it? And then once you have that, like, in a very clear way, hopefully maybe with a DAC, or I don't know, you find another way to represent it. Once you represent it, you can start to play with it and get insights from it. That will be what I would recommend, more than a tool. Again, you can use any tool.
100% agree. So there is a lot of times we focus a lot on solutions and that are in the market, while the basis of success or not of our objective is based on how well we can define the hypothesis,
Mm-hmm.
how we can remove all the noise around it,
Yeah.
focus just on a clear hypothesis that can be validated through an experiment. Because obviously any experiment has biases, but if you can check specifically what is your hypothesis, you can validate this and um, validate the hypothesis.
Yeah.
This is interesting. Now, if you were some analyst that is starting right now to uh, go inside of this journey of marketing science, right?
Mm-hmm.
And wants to start diving into marketing mix modeling, causal inference, uh, all how to set up an hypothesis and why, how to define an hypothesis and how to test it. What suggestions would you make? Would you give?
I would say that the first is you really need to understand your data. So a lot of data, like data exploration, pops in. So spend time understanding how your, again, underlying process of, we call it data generation process, how it works. Um, and you can, again, just go do queries, and just start to test. I don't know. Let's say that I imagine that people in Rome, they get their salaries in the end of the month, every 30. So by consequence, I believe that we have some kind of seasonality around it. So just do a query, see your data, check if that pattern repeats. If that pattern repeats, then maybe you're going to start to, again, formulate an hypothesis around it. Or you can validate it with another, I don't know, market that is similar to Rum, or do know. I mean, I will say that I don't have a specific formula to define like your hypothesis more than do research, because the path to find your hypothesis, to be honest, it's very particular for every company. But the only thing that you can use is, again, data exploration. So really invest time in understand your information, your data, and try to be very try to make questions by like around everything, around every point that you believe that it's interfering in your target. Make a question around it, put it into your board, and think if, changing this specific node, this specific action, something will change by the end of the day, and move from there to for sure test it.
Definitely. So if we need to summarize it, so first, essentially, is to centralize data into some place. And after we centralize it, we can start with an exploration analysis, starting even from a scatter plot that we can run between an output variable and an input variable. Can be how much I spent versus how much revenue I generated. So we can start seeing visually what can be the hypothesis, how much revenue changes and how it correlates with the variations in spend. I won't dive into multicollinear effects, which are more technical and super into it. What I want to dive into in these last minutes is, before Q&A, is Bayesian statistics versus the frequentist methodology. Generally speaking, the utility that it generates. So there is this topic that Bayesian is probability-based. It's a probabilistic methodology to measure marketing performances. It's harder to get and to calibrate compare a frequentist methodology. I want to get your take on it, and why PyMC marketing and Bayesian statistics, and why is it better in specific contexts for marketing measurements?
To be honest, I mean, I don't like to. I really don't like that question between Bayesian against statistics, for the same reason that both are like tools, like both are ways to approach problems, and you can solve one problem with one or the other. So, but I really believe that sometimes Bayesian have some advantages, and the advantage of that I see from Bayesian modeling, it's because can be very causal. And in that sense, again, when you want to do an experiment, I mentioned you have this DAG about like how reality works. And if you want to do a quasi experiment or any kind of experiment, really, you also need to understand how reality works and which nodes you are changing in order to get certain impact. And then you make it clear, you do your experiment, you hold your conditions, and then you see if you can relate that change to what you move in your internal data structure, underlying data structure. And in Bayesian statistics, you can actually do the same. You can, when you're doing the model, you need to be very explicit about this data generation process. It's not only put factors, like in frequencies, you put like basically all the factors,
Yep.
you turn the blender, you get results. And again, that works in a lot of different cases and scenarios. This is not, again, not a bad thing. I will say that even, I don't know, in the last 20 years, maybe we have more frequencies results than Bayesian results, because Bayesian is also getting like popular, I would say, in the most recent years. But although you definitely need to, in Bayesian, make all of these assumptions transparent, all of these all your belief around this data generation process will be just right into your model. If you go to a PyMC model, that's why when you build a model, you have these graphics that you basically shows you what you are modeling and how each variable is related. And why this is important is because with MMN, we are not seeking predictions. We are not trying to estimate the future. What we are really trying to do is decompose what happens. And decomposition, I would say that it's the core. And if you want to decompose your information correctly and at the same time in a very robust way, what would be better than be super clear around all the hypotheses that you did before get the decomposition. And what I see, for example, when I, for example, try it in Excel, the regular frequencies methods, or with scikit-learn, or with, I don't know, all the other tools that you have around, is that you don't have this clear. I mean, this is still exists in frequencies. You still have some data generation process underlying, but you don't have it clear. So you get your model, you do their fit, and then you get, like, I don't know, negative intercept, or then you get some, I don't know, strange things, or I don't know, one coefficient is like super good and the other is super bad, and you cannot understand why the model is basically giving me this information. You understand that I have an underlying function that is optimizing and is trying to reduce the square error so we can just get a better fit. But at the same time, sadly, a very amazing fit is not actually is not a variable that we could use to understand causal impact of our variables or to judge the decomposition of our model. So again, we can have amazing fit, and you go to the parameters, you go to the coefficients, and it's crazy. Doesn't make sense if you translate that to real life. And that's something that with Bayesian you not solve, because still you can get some strange things. But given the fact that you model everything from scratch, that you were transparent, that you were like clear with how my data works, what are the assumptions that I'm doing, if something doesn't work, then you know where to go to switch it, to twist it. You have more comprehension about the model, and that's essential, because that's basically, sometimes you do your model, something is totally incorrect, and that's give you the input that you did the model wrong, or you build incorrectly the GDP, or I don't know, you are maybe using very strong priors, and you are like basically crashing your model. You get divergences, and all of these signals, again, in a regular framework where you didn't went through this process, you will be like, okay, how to proceed, right? You will just sit there and, okay, I get, I don't know, negative intercept -5. Why? Not sure. Let's refit with more data. And that's the solution. And then it's like, tricky. I don't know. What do you think?
I mean, I think so. First of all, I think you answered beautifully to my provocation, because obviously, you said right. There is big utility in frequentist methodologies, especially when you're starting out, because it's easier to adopt, and they can actually help you to make decisions in your marketing mix. The Bayesian approach is really useful when you start understanding that your decisions are just bets, and you want to bet in in a location that has the highest probability of yielding a positive result. And if you start switching your mind from deterministic decision making to probabilistic decision making, understanding what is the uncertainty of each model, understanding the probability of achieving a goal, Bayesian statistics is really, really helpful, because it has embedded in it all these uncertainty measurements that can actually help decision making. It depends mostly, to my opinion, on the stage of the company, whether they have enough knowledge inside in order to make these decisions, because most of the companies are not there yet. Most of the companies need to remove friction to their measurements really fast. And frequentist, the methodology that's been used so far, it can be okay if they have a really high understanding of how to make decisions in a probabilistic way. I think Bayesian is an incredible option. And by the way, I open a small parenthesis. If you want to try Bayesian statistics, there are 3 open source libraries that you can use. One is famous Google Lightweight MMM. The second one is Orbit. And the third one is PyMC Marketing. From my experiences, I've tried all 3. the easiest to use, the yield a result that is actually useful at the end. It's from my experience, which is really little. PyMC is is getting an edge. They're really fast at deploying, and Carlos here is one of the contributor of the open source library.
Yeah. No, I first thank you for the mention. I will really I will say that I'm really happy if new people start to use our technology, like the technology that PyMC is just developing. So again, thanks for that. But I'm totally agree with the point that you're touching, that not all the companies have had those capacities. That's actually the reason why we are trying to move open source softwares like PyMC marketing, just to make it simple, because we understand that it's not an easy task to go to like Bayesian modelings and start to develop them from scratch. But at the same time, as I mentioned like before, you really need to understand the stage of your company. For sure, a very small company, maybe they don't need MMN. Maybe they are okay with experiments. Maybe they are more mature. Then let's go for MMN. As you said, we can go for a frequencies approach that we can again be very certain about what we are doing. If we are certain and we are like clear and transparent about all the things that we're having around, why not to use it and get some response and take decisions from there? You can get linear insights still to take decisions. You want to do one step, another extra step, then for sure you can go for more like complicated things, and that's totally normal and that's totally okay. But that's again a stage of your company. Sometimes for both, for example, or wise, maybe doesn't make sense to 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 get, I don't know, external. This is not related to MMN, but for an example, for us, doesn't make sense to get an external agency to do all advertising, because we are so big that for us it's just better build an internal team. That could be the same case if you just translate it to MMN. Sometimes makes sense get external stuff. You are like not crazy. Maybe you also make sense if you're like as well like super big in the both ways, but you just need to define it as a company. So yeah, that's all what I wanted to say.
Awesome. Carlos, what you think we can dive into some questions?
Sure.
There is one question from Alexander Bolak from you. You
Nice.
systematically translate the results of RCTs into structural assumption for your MMM.
RCTs. I'm actually.
I believe that he's referring to some experimentation.
Yeah, probably. Sorry, I'm not kind of familiar with that RCTs, but so that's the result for. Yeah, I mean, I systematically introduce like my experiments to to MMNs for sure. I mean, once we do experiments to generate informative priors for our models. In my case, so yeah, once I get like 10, 12 experiments or something around, I'm going to start to build a distribution about all of those results, given also the fact that each experiment that you're running is in a specific period of time. So they not necessarily like replicate. If you do something in December and you test the same thing in May, results can be different, can differ. And we also want to understand this variability across time. So once we get all these experiments, you can get a prior about how much each, I don't know, channel is contributing to your target variable, and then you can just pass it to your MMN, like as a prior in the case of PyMC.
Yeah. From my experiences with more models in the frequentist approach is you can actually implement some priors, not as a Bayesian framework, but stating what is the confidence interval of a specific contribution in a certain time frame. And in an easy way, you can actually insert the results of your experiments inside your marketing mix model before training.
Yeah.
And it's going to optimize not only for prediction error, but it's going to optimize also to match the contribution with your own prior that you set.
Yeah. By the way, I think that I found randomized control trials is what he means by RCTs. I imagine. Please, Alexander, correct me if I'm wrong. But if it's that, yeah, I same thing that I just replied. Once you have the result of your experiment, either if it's randomized or not, you can pass it as prior information to your model.
Definitely. So there is a new questions from Pawan Rai. Want to know how to validate? How do you validate? I mean, how do you confidence to stakeholder? How do you say to your stakeholders that your models are really very accurate? Any validation process?
Yeah, I mean, I was that's we go back to experimentation. So one of the ways that I validate my models is you get when you do the model, you get a response curve, what we call this diminishing return curve. So you just plot a spend in X and estimated contribution in Y, and that should have this, like curvy line basically. When you if you increase your channel from 0 to, I don't know, 100 spend, that will give you a certain contribution. You can measure it with any quasi experiment framework, and that dot is basically, you went to a 100 spend and you get 10 contribution, and you can just plot that dot into the curve. If the dot is usually under the credible intervals of your model, you could basically say that your model is doing a right work. So you are confident that your model is representing reality as you expect. That is what we are not searching like best again R square or MAPE or whatever else. We want causality there, and the way to kind of infer that causality to make our model not correlational model, instead causal model. We need to do these experiments and see that our model is capturing like the real values that that are affecting our target variable. So yeah, you get response curve, you do the experiment, you get the dot, you put the dot in your plot, and you repeat that process. If at some point you find that your dots are going like outside of the confidence intervals, or they are not even close to that even at the beginning, then is when you need to take that information, put it into the model, and start to do the correction of your model. And again, when I mention correction, and I just want to be clear here, it's not just force the model to have the response that that specific experiment give you. If you start to correct your model every time that you do an experiment, you will end up in a moment where you're like correcting all the time, because again, usually these models that we build, at least for example in PyMC, we are not considering um, variational coefficients, and we understand that time is also that affects like the performance of each channel. So you need to be very careful that after certain amount of experiments, you can estimate a mean estimation, and that mean effect should be close to your curve, because the curve is actually estimating the mean of your effect over time. If not, then is when you need to correct. But yeah, that's all. Like you need to be careful how you calibrate. It's not just calibrate by the sake of calibration.
Yeah, I 100% agree. One other thing that so the only way to validate scientifically is as you shared. One thing that we can do in order to uh, measure the robustness of the model is training with train test splits, or doing cross validation to see how well the model could actually predict sales in periods in which with data that he did not use during the training. Or it's incredibly important to focus on uncertainty and assess uncertainty inside your model. One way to do it, even if you do Bayesian or if you do frequentist approach, take a look at the ROI confidence intervals. I see a lot of tools that do market mix modeling that show deterministic ROI measurements or CPA measurements in their market mix. This is impossible. This is not reality. The reality is that there are a list of values that have the highest probability of being true. So based on how wide your confidence intervals are, you can assess what is how much uncertainty there can be in your model because of multiple biases on your data, which can be multicollinearity, few records in your data set, etc. But it's incredibly important to assess uncertainty in any model that that you see, because models are a simplification of reality, and reality changes a lot, and you need to be able to assess uncertainty in it. There is another question here from Amin Ankar. By experience, what is the most suitable AI algorithm that you can consider in MMM to do predictions?
Okay, that's a good one. I mean, I would love to know what you mean by AI algorithms. Like, like we have a lot of different ways to do estimations and predictions. And I don't know if you mean like, I don't know. I actually don't find what you want to mean. Maybe Gabriel, you can give me light there.
So, I mean, in this case, AI algorithms is, it can be anything. It can be
Yeah.
really anything, but it depends what you want to predict. If you want to predict seasonal patterns, probably uh, Arima, Prophet,
Oh,
tools
yeah.
that
Okay.
can detect patterns can be extremely useful. Do you
Yeah.
want to, yeah,
No, no, go ahead.
if you want to predict something that can, so if there are some independent variable that can describe an output like marketing mix modeling is, and there are dependent and independent variables relationship inside, probably marketing mix modeling is one of them if you're predicting marketing data and marketing sales data. There are LSTMP, I don't remember the acronym, but
Mm-hmm.
they can predict the future sales based on the current value of your of a stock, for example. Is mostly used in the stock predictions. But I mean, it depends what you want to predict. So I would probably define what is the metric that I want to predict and what influences that metric, and then derive what is the best approach and the best algorithm to use in order to solve this problem.
Yeah.
What do you
Yeah, I
think,
actually
Carlos?
no, no, no. I just wanted to mention that if you just mean like the method, like the model method for the regression, as you're mentioning, like I don't know, ARIMA, LSTM, or whatever. Um, Again, really depends on tops down again to your business case. So as you
Yep.
said, if you want to do some seasonality stuff, that's fine. I honestly really like right now these structural time series models. So I use a lot this TFP from Google to work around it, or if I want just to work like and detect seasonality, all of these Gaussian processes that you can use in PyMC are like very useful. So yeah, I will say that maybe Gaussian processes is right now my choice if I just want to detect like seasonality patterns or latent like patterns as well in your time series. But again, and they are like very good to predict, by the way. But yeah, that's for predictions again, and I'm not sure if MMN is a prediction problem. It's more like a composition problem.
True. 100% agree. We have the last question. I believe it's in line with this one. And do you take time varying coefficients into consideration? All stakeholders feel that their marketing efforts will have varying effect based on seasonality. So to give context before giving an answer is, there are two ways of attacking incrementality and measuring incrementality effect in marketing mix modeling. One is giving the contribution of seasonality directly to seasonality. So you will see that because it's December, you do 300 incremental sales. And there is then another approach that says that the efficiency of marketing investments changes over time. So your ROI changes from 3 to 10 between August and December if you're selling trees for Christmas. because there is just more demand and the demand increases, but the contribution is attributed to the media. It's not attributed to the seasonality. What's your take on that and with the PyMC framework?
Right now, what we believe that should be happening is, as you mentioned, seasonality sometimes affects two ways. The effect of seasonality is not only in the target variable, also affects how your ads perform, right? And I really like this new article from Google where they, like, in purpose, in their data generation process, in their DAG behind the model, they make seasonality kind of a co-founder that is not only affecting one side of the full model of the data generation, they are affecting, again, the final outcome, that is total sales, but at the same time is affecting, I don't know, search volume or impressions. So these two things will exponentially grow off. And this is a way that kind of you can start to clean the noise around, for example, how much your performance in a certain period can change, and how that same change can be reflected in your sales, just because it's seasonality for, again, not seasonality of the platform, it's seasonality of the business. That's one way to tackle down. But again, this is very novel, I would say. When I say novel, is that you don't see so many models that are doing this kind of modeling, by the way, like out there. We are trying to bring it to put it into PyMC. But another maybe easiest way to take is, once you get all the impressions that a channel is giving to you, and also you understand the spend that you're putting to get that level of impressions, you can divide basically one for the other, and calculate the CPM for, like, your historical CPN, and you can see how that CPN move. And I mean, if we understand that Facebook, Google, and all these things are just bits, when our CPM go like higher, it's basically because we have like a lot of people also in the platform that maybe they are putting the money to catch the same audience, so we get expensive. And when the opposite thing happen, basically we go cheap. And just understanding that, we can start to think that at some point, if you go expensive, then maybe your performance should decrease by consequence, like directly. You got expensive impressions, maybe you just are getting the same amount of return, but the double of money. And that can give you already the insight of platform seasonality that is independent to, like, business seasonality. And that's a way to tackle down as well, without make your model like super complex and start to add stuff. So yeah, that's the way to consider that. That's the way that I'm using to consider time variational coefficients right now. Not time variational coefficients per se, but split in these two different types of seasonality, and consider it into my model. So I just get a general model that estimates the overall impact of impressions against my target variable, and then that impressions can be translated to a spend based on the cost of CPN, and the CPN can vary over time. And that's basically allows me to have like several several diminishing returns curve. In my case, I usually do it by month, so I get one curve for January for the same channel. I can see the curve for January, the curve for July, and so forth. And each curve, time based, they have their intervals as well, like their credible intervals. You can see some explanation about it when I do this time-based, even budget allocation time-based, because how you allocate budget in January and May becomes very different once you understand that relationship as well shift over time. I have an article where I explain it in my website. I can just share the link in the thread.
Actually, this is amazing. I didn't think about it. So you create a proxy of CPM in order to understand how cheap it is to advertise, in order to tackle this varying problem that happens over the year. It's amazing. Well, I think we went a little over it, 11 minutes over it, and this has been an incredible chat together. I thank a lot, Carlos. Thank you a lot for being here and sharing your knowledge with everybody. probably maybe we'll do another in the next few months if someone wants.
Yeah.
But thank you a lot for having you here and attending this fire chat. We will share with everybody all the documentation, all the articles and useful information that we mentioned in our chat through email and through LinkedIn to all the participants of this webinar. Awesome.
No, that's nice. Really, thank you for having me, by the way, and hope that I tried to reply like all the questions. Sorry if I didn't catch some of the shorts versions or acronyms. So next time, but was a lovely meeting. So really thank Gabriel.
Thank you.
Bye.
So have a great evening, everybody. Bye-bye.